Welcome to the deep dive.
Hmm.
I want you to imagine, just for a second, that you are at the beach.
Oh, I love the beach.
Right. You are having the perfect summer vacation. The sun is shining, the water is cool. But then, somebody points out toward the horizon.
Uh-uh.
Yeah? You spot a gray dorsal fin slicing through the waves. Instantly, your stomach just drops. You, and I mean literally everyone else around you, sprint out of the water in absolute terror, convinced you just narrowly escaped a gruesome fate.
The classic Jaws scenario.
Exactly. So later that evening, you're back at your hotel and you're still, a little rattled from the beach. You walk into the lobby, you look at the elevator, and you just decide to skip it.
Because you're already feeling vulnerable.
Right. You think about those enclosed spaces, the snapping cables plunging down a dark shaft.
Yeah.
So just to be super safe, you decide to take the concrete stairs up to your room.
And honestly, in the moment, that feels like the responsible, practical choice. Like you're taking control of your own physical safety after a big scare.
But here is the massive reveal we are bringing to you today. In that specific scenario, you have completely, almost comically, misunderstood statistical reality.
You really have.
You have just run away in absolute terror from one of the safest animals on planet Earth, only to willingly trust your life to one of the deadliest structures in modern society.
It's wild. We are just spectacularly bad at calculating real-world risk. Our brains obsess over the spectacular, and we completely ignore the mundane, which leads to decisions that make us statistically much less safe.
And that is exactly the mission of our deep dive today. Using this really fascinating stack of sources, we've got Consumer Product Safety Commission reports, behavioral safety studies, risk analysis blogs. We are going to recalibrate your perception of everyday dangers.
It's going to be a total paradigm shift.
We are going to unpack why you are so terrible at assessing statistical likelihood. And ultimately, our goal today is to convince you that the common staircase is a hidden menace. So, okay, let's unpack this, starting with your fear of the ocean.
Yeah, the ocean is a great baseline because it perfectly illustrates our cognitive blind spots. We are still living in the shadow of the Jaws effect, which has terrified the world for, what, decades now?
Oh, absolutely. And honestly, deep-sea divers often compare sharks to, sea puppies.
Sea puppies! That's perfect. Because if we look at the actual data from the ichthyology department at the Florida Museum of Natural History, there are only about 1 to 5 shark-related deaths annually worldwide.
Wait, 1 to 5 in the entire world?
In the entire world. Your lifetime risk of a fatal shark attack is a staggering one in 3,748,067.
So it is practically zero.
Yeah.
But if someone spots a fin at the beach, there is total panic. Contrast that with, say, taking a drive through the countryside and encountering a cow.
Right, the cow.
Your first instinct is probably to walk up to the fence and try to pet it.
Right.
There's no dramatic cello soundtrack playing in your head.
No, which is entirely backward. Statistically, you should be sprinting away from that pasture. Cows kill an average of 22 people per year in the United States alone.
22.
Yeah. And horses kill about 20. And if we are talking about real animal menaces, I mean, mosquitoes spread malaria and kill hundreds of thousands of people every single year globally.
It's crazy. And honestly, with cows, we literally eat them, and we don't always treat them well, so they're smarter than people think. If you've ever mistreated a cow, it's probably best not to turn your back on them.
That is very true. They are large, powerful animals.
It just seems like we equate the word danger with unfamiliarity. Like, I don't swim in the deep ocean every day, so my brain flags it as a massive threat. But I see cows on milk cartons, and on TV all the time. My brain equates their ubiquity with safety, and this logic doesn't just apply to animals, right?
Oh, it absolutely applies to inanimate objects, too. Let's look at the vending machine in your office hallway or a hotel lobby. A vending machine is roughly twice as deadly as a shark.
Wait, I need a second to process that. The machine dispensing my afternoon potato chips is statistically deadlier than a great white shark.
I know it sounds absurd, but the numbers don't lie. The lifetime risk of dying from a vending machine accident is 1 in 112 million. Between 1978 and 1995, 37 people were crushed to death by these machines.
37 people. I'm trying to picture the mechanics of how that even happens. I assume it's not the machine, aggressively attacking someone.
No, they aren't sentient.
Right. It has to be a user-generated event. Like a snack gets stuck in the coil, the person gets really frustrated, and they try to shake the machine to dislodge it.
That is exactly the mechanism. A frustrated person tilts the machine forward, trying to use gravity to get their snack, but they drastically underestimate the weight of the machine, and once it passes its tipping point...
It just comes crashing down.
Exactly. The massive weight comes right down on them. What's fascinating here is how the sheer ubiquity of these machines lulls us into a false sense of security. There are roughly 3 million beverage vending machines in the US alone.
So because there are 3 million of them, and we see them in every break room, every train station, our brains just absolutely refuse to classify a massive top-heavy metal box as a physical threat.
Precisely. We fear the unknown, like the deep ocean, which we cannot control. But we completely ignore the dangers we interact with daily because they are familiar to us. And this exact cognitive blind spot is why we don't think twice about the physical architecture we move through every single day.
Which brings us back to that hotel lobby, the choice between the elevator and the stairs.
Hmm.
You look at an elevator door, and your brain instantly conjures up every disaster movie you've ever seen.
Die Hard, Speed, all of them.
Yes. Do you imagine the cable snapping and just being trapped in a metal box, plunging downward?
But elevators are incredibly safe. The engineering behind them includes multiple redundant braking systems. In the United States, there are only about 27 to 30 elevator-related deaths a year.
And crucially, about half of those fatalities are the mechanics and maintenance workers who are actively working inside the shafts, right?
Yeah.
Not the passengers riding in the cabin.
Exactly. Elevators have literally elevated humanity safely to a whole new level of modern living.
Literally elevated. I love that. So my fear of the elevator isn't a rational assessment of risk. It's just claustrophobia wrapped in a Hollywood narrative. But while I'm patting myself on the back for being safe and choosing the stairs, I am actually walking straight into a statistical nightmare.
It really is an epidemic of injury. Let's pull from the 2024 Consumer Product Safety Commission data. Injuries related to stairs, ramps, landings, and floors account for a jaw-dropping 3 million emergency department-treated injuries every single year.
3 million ER visits.
Just from walking.
Just from walking. And when you factor in medically attended injuries that don't result in an ER visit, that number skyrockets to over 7.7 million injuries annually.
Wow, that is a staggering slice of the population getting hurt just trying to move between point A and point B. And the fatality numbers reflect that severity too. Falls account for 70% of all consumer product-related deaths. In 2023 alone, there were nearly 42,000 deaths resulting from falls. When we isolate that data to falling downstairs specifically, it results in an estimated 1,600 deaths each year.
Okay, here's where it gets really interesting. Usually when I hear statistics about fall fatalities, my mind immediately goes to nursing homes, right? Like the elderly.
Sure, that's the common assumption.
It makes sense that frail bodies are more susceptible. But looking at 7.7 million medically attended injuries, that math doesn't work if it's only happening to senior citizens. This has to be happening to everyone.
You're spot on. The age 75 and older demographic does have the highest death rate. In 2024, there were 37,400 deaths involving falls for people over 65. So the vulnerability there is absolutely real. But the injury data proves this is a universal hazard. The sheer volume of traffic on stairs makes them danger zones, regardless of your age, your reflexes, or your physical fitness level.
Which completely undermines all those wellness campaigns that constantly tell you to, take the stairs for your cardiovascular health.
Oh, absolutely.
If you want to get your heart rate up, you can get exercise safely on flat ground or on a Stairmaster at the gym. Taking an unnecessary risk in a concrete stairwell just because there seems like a terrible trade-off, especially when you think about where stairwells usually are in big buildings.
What do you mean?
Well, they're usually isolated, right? And fireproofing is kind of similar to soundproofing. If you take the stairs alone and get hurt, people might not even hear you calling for help.
That is a terrifying point. And it leads us to the core question, which is what exactly is going wrong mechanically when we use a staircase? Because if millions of people are getting injured, we can't just chalk it up to isolated moments of clumsiness.
Right. There has to be a systemic breakdown. It's either a failure of physical design, a failure of human biomechanics, or a catastrophic mix of both.
It is definitely a mix. Because if we connect this to the bigger picture, you have to understand the mechanics of human movement. Humans are bipedal, right?
Right. We walk on two legs, unlike most other creatures that walk on four or more.
Exactly. Because we walk on two legs, we operate on a very delicate balance. Every single step we take is literally a controlled fall. And sometimes you lose control and it becomes an uncontrolled fall and you get seriously injured.
That makes so much sense. A controlled fall.
A CDC and Georgia Tech study on occupational stairway falls found a massive 92% of injuries happen when descending the stairs, not going up.
92%. Which, that makes sense from a physics standpoint. If I trip while walking up the stairs, my forward momentum is immediately stopped by the staircase structure itself. I might bang my knee or scrape my hands, but the structure catches me.
You sort of just fall into the stairs.
Yeah. But when I am descending, gravity is actively pulling my mass downward into open air. I have a much greater distance to fall before anything stops me.
Exactly. The primary culprit in these descent falls is something researchers call overstepping the tread.
Okay, let's break that down without the jargon.
Mhm.
What does overstepping the tread actually look like in real time?
It happens in the fraction of a second just before the fall. A person misjudges their pacing and they place their foot down slightly too far forward on the step right before the one they actually slip on.
Oh, I see.
Because their foot lands too close to the edge, what we call the nosing of the stair, their body weight doesn't distribute across the flat surface. All of their downward force shifts onto a minimal surface area right at the edge.
It's like walking downstairs is a high-stakes rhythm game. Our brains enter this kinesthetic autopilot where we expect every single beat, every single step to be exactly the same distance and height. If one misjudged distance ruins your combo, your foot slides off that minimal surface area and you are going down.
That is a perfect analogy, and our built environments constantly betray that autopilot. Incidence rates of falls spike dramatically when the design of the stair deviates even slightly from our kinesthetic expectations.
Like if a step is just a tiny bit off.
Exactly. If the tread depth, the flat part you step on, is narrower than 10 and 3/16 inches, or if the vertical riser height is taller than 7 and 1/8 inches, accidents just skyrocket. If a single step is even half an inch taller than the one before it, your brain doesn't register it, your foot expects solid ground, and your rhythm fails.
Wow. Half an inch is all it takes to ruin the rhythm. I'd imagine the material of the stairs plays a huge role in recovering from that broken rhythm, too. Slipping on a perfectly smooth, polished concrete stair in a modern office building seems like the absolute worst-case scenario. It's basically a ramp at that point.
You'd think so, but the data is counterintuitive here. Surprisingly, linoleum and tile stairs cause far more descent incidents than concrete or stone.
Wait, really? Because even polished concrete has, like, microscopic texture to it.
Yes, it's about friction at the exact point of failure. The rough tooth of a concrete or stone stair can actually catch the rubber of a slipping shoe. It acts as a final brake, preventing your forward momentum from carrying you completely over the edge. Smooth linoleum or tile offers absolutely no resistance. Once you start to slip on tile, the friction is essentially zero.
But it's not just the architectural design, is it? We're constantly sabotaging our own rhythm game. We introduce visual deceptions or carry large objects that completely change our physical profile.
Oh, human error and distractions are massive triggers. Think about carrying a large laundry basket or a heavy box down the stairs.
It physically blocks your vision of the step edge, so your brain can't even try to correct your kinetic autopilot. Plus, holding a heavy box extends your body's mass beyond your normal base of support. You are essentially shifting your center of gravity out into the empty air in front of you.
Exactly. And when you combine a compromised center of gravity with a slight variation in lighting, or a riser that is a quarter-inch too tall, a catastrophic fall is almost guaranteed.
So if human biomechanics and stationary stairs are such a disastrous combination, it makes total sense why we tried to engineer our way out of the problem. If we can't reliably walk downstairs, we'll build stairs that move for us. The escalator seems like the ultimate technological fix.
It seems like the perfect solution. You just stand still and let the machine do the vertical movement. But replacing stationary concrete with moving metal machinery introduces entirely new, horrific risks. Injuries occur about 15 times more frequently on escalators than on elevators.
15 times more frequently.
Yes. They result in around 6,000 hospital emergency room visits annually.
Wow. Which demographics are absorbing the brunt of those escalator injuries? Are we back to the elderly population?
The demographic vulnerability is very specific here. Escalators disproportionately harm children under 5 and adults over 65. Now, when escalators make the news, the high-profile stories almost always focus on entrapment. You hear the terrifying accounts of a child's hand or dangling shoelaces getting sucked into the cone plates at the top or bottom of the machine.
Yeah, those entrapment stories are visceral. They really stick in our collective memory because it feels like the machine is actively harming the rider, like it's eating them.
But they obscure the statistical reality. Here is the surprising data point. 75% of escalator injuries are actually from falls, not entrapment.
75%. So even when we remove the need to physically step down, the sheer act of standing on a moving incline is still causing us to collapse.
Because the continuous movement prevents a human from resetting their center of gravity once it's lost. And it's not just falling down the metal steps. A staggering 29% of falls that occur over the balustrade, the handrail, result in fatalities.
Wait, plunging over the side of the handrail. I'm trying to figure out the physics of that. Unless someone is actively doing handstands on the escalator, how does a standard rider end up falling over the side?
It usually comes down to friction and the continuous drive of the machine. Sometimes a rider stands slightly too close to the edge, and the friction of their clothing catches the moving rubber handrail.
Oh, I hate when that happens.
Right. And because the handrail is pulling them forward, it rotates their upper body and pulls them off balance. Or they simply lean over slightly too far to look down to the lower floor.
And because the ground beneath their feet is constantly shifting forward, their kinetic autopilot can't plant a foot to push back against the momentum.
Exactly. They lose their center of gravity, they can't recover, and they plunge over the edge, often multiple stories. We put moving metal stairs over massive vertical drops in crowded shopping malls and transit centers, and we rely entirely on the general public maintaining perfect, static balance.
And when you introduce extreme crowd density into that equation, the mechanical strain on the system must magnify these design flaws drastically.
Heavy usage exposes these vulnerabilities in terrifying ways. Look at China, which houses an estimated 44% of the world's escalators. The immense demands placed on public transit infrastructure there have led to catastrophic mechanical failures. In one highly publicized incident in a Beijing subway, a massive crowded escalator suddenly reversed direction under the weight of the passengers.
Oh my God.
Yeah, it resulted in 1 death and 30 injuries in just a matter of seconds.
So we can't reliably walk down stationary stairs without falling, and escalators, our grand technological fix, turn into moving traps that prevent us from regaining our balance. It feels like we're just losing a battle against our own vertical architecture.
This raises an important question about how we regulate the spaces we build. Engineers and safety advocates are urgently calling for updated designs to mitigate these risks. They are pushing for flush surfaces that eliminate ledges people can climb on. They want narrower handrails that are easy to grip but impossible to sit on to prevent people from riding the balustrades.
That makes sense.
And most importantly, they want much higher and stronger fall guards installed on the sides of the machines.
But the reality of physical infrastructure is that it moves at a glacial pace. We can't just issue a software update to a massive metal machine bolted into a concrete shopping mall. Escalators have lifespans of decades.
They do. The machines installed 20 years ago, with the older, more dangerous specifications, are still moving millions of people today. So this specific architectural risk is going to remain in our environment for a very long time.
Okay, let's wrap up this deep dive, because I think we've successfully ruined the concept of walking between floors for everyone.
Yeah.
Let's summarize the journey we've been on. You came into this scenario terrified of the deep ocean, scanning the horizon for sharks that cause maybe 5 fatalities a year globally.
Barely a blip on the radar.
Right. But you are leaving with a very healthy respect for the vending machine in your office hallway and the staircase in your own home. We've learned that elevators have literally elevated humanity safely. And when in doubt, you should absolutely trust the box on cables. Do not feel guilty about skipping the stairs because your cardiovascular health can be improved much more safely on flat ground.
And as you move through your day-to-day, my call to action for you is to actively notice the built environment around you. Don't just operate on kinetic autopilot. Look at the tread depth of the stairs you use. Notice the materials under your feet. Consider whether you are walking on smooth tile or rough concrete. Recognizing the design of our world and where its physical flaws meet our biomechanical limitations is the first step in safely navigating it.
I love that. And I want to leave you with one final lingering idea to chew on. We spend our whole lives viewing buildings as passive shells. We think of them as just inert structures we happen to live and work inside. But if the human body's sense of balance is so delicate that a routine descent can be turned fatal by a concrete step being half an inch too tall, well, maybe we need to change our perspective. Maybe we shouldn't view buildings as passive objects at all. Maybe they are invisible behavioral obstacle courses that we have to actively, constantly survive. The next time you approach a flight of stairs and take that first step into the void, ask yourself, who designed the fall you are about to take?